It's a very basic, understanding. Just what I have done, I have created these are the two things that you have to use to understand this. That is, first, train test split. This is not stratified train test split. Okay, this is a simple train test split. What I have done, I have created a data set actually, okay, by this make blobs function presented in the sklearn dot dataset. So it is representing 100 comma 2. What does it mean? It means that the total number of features is 2 and total 100 points are there. So y dot shape is 100, means total 100 number of points. And I want to divide into two part, test and train. So train test means for training you will have a x and y. For testing you will have a x and y. X means number of x is the feature, y is the output. So that's why it is written as C. When you will call train test split function, it returns four things: x train, x test, y train, y test. X train corresponding to y train and x test corresponding to y test. Remember, just why what I showed in the in my previous thing. So here you see the test size I have given 0.33. What does this mean? It means that 33% data I am choosing as a test data and 67% will be used for train data. And after dividing the whole data set, that is x is the whole data set whose corresponding output is y. Okay, if I do this, and if you run this code, you will see that what it is representing, x train, what it is representing, it is representing first 5 samples, as simple as that. Okay, now the thing is that you see I have written the same code again just to show you that if I try to do the train test split again, I'm going to get the same set of data here. You see, if you compare these two, you will see there are same set of data. There is no change, right? This is normal train test split. But in those cases where you have a very imbalanced data set, then we have to go for stratified train test split that I've just said. So for this purpose, what I have done, I have created a data set again. You see, where in case of most of the, there is a difference between the distribution of the two different classes. So I'm just trying to run the code, and you see the whole dataset distribution given as this. What it is representing? It is representing number of 0. The output 0 have 70 cases, output 1 has 30 cases. Okay, so naturally the classes 0 and 1 is not balanced. The classes 0 has high number of lot of more, almost more than doubled amount of data than one class, right? Now if we don't apply stratified train state split, then what will happen? There will be a chance that most of the train data come from this class and very less data come from this class. So naturally what will happen? The model will more biased for the 0 class, which should not be the case. That is why we go for train state split. I mean stratified train state split. And what we do here, you see here, just to, you see, for stratified train test split, there is no other function. The function is train test split itself, but there is a parameter added here, which is stratify equal to y, which was not present in my previous function call. So due to this particular parameter, what will happen? Automatically, this particular function will divide the x train and y x test in such a way, considering the distribution of 0 and 1 in mind. Just you see here, that's why I have printed the number of 0 and 1 present in both train and test data. what do you see? First of all, you have seen test size is 0.30. That means 30% are test data, 70% is train data. So 70% train data means among 70 plus 30, total 100 cases. Among 100 cases, 70 will be total 70 cases will be for train, 30 cases will be for test. You will see if you add the number of zeros and number of 1 for train data, it's 49 plus 21 is 70. 21 plus 9 equal to 30. Now question is that, is it really maintaining the proper distribution of 0 and 1 for both train and test? You see, in case of train data, number of 0 come 49, number of 1 is 21. For test data set, number of 0 is 21 and number of 1 is 9. Just to check the percentage retained same for both train test, what I have done, I have checked how good it is. That 21 0 1 among with respect to 0. So 21 by 49 and 9 by 21. Just I have checked the ratio of 0, 1s and zeros in train and test data. And you see the ratio is same. That means the distribution of zeros and ones happens in train and test perfectly. If you create a machine learning model using this train data and try to test it, that means I can guarantee at least that they are in the same distribution. So nobody can claim that the model is worst because it's taking from different distribution, or model is very good because it is in the same distribution, something like that. They are actually in the same distribution. So in this way you can divide the data set into two parts. Okay. So up to this, what we have done, we have completed the data processing tasks. So if I just go back for a moment, just to end this lecture, let's go back for a moment. So we have completed the data processing steps today. We have completed. Now the next step definitely is building the model. But you know, after building the model, how will you understand the model is good? You have to evaluate that, right? So that's why what I planned is that before we start building the models, because once the model building will start, we will basically go through a lot of algorithms. So mostly we will invest our time in this middle part. But only model building is not important, right? We have to test the model, we have to make the prediction, and we have to check how good it is predicting. That's why evaluation is very important. So that's why what I planned is that before we start building a model, we must know what are the different ways by which we can evaluate a model. So that's why in the next we will jump this second middle part. We will go to evaluation step. We will see different type of performance metrics, just what I was discussing during splitting of the data set. And then we will come back to the second stage and we will go through the different machine learning algorithms one by one, and we will try to also implement that, and we will check how good the model is behaving, and then we can compare which model can be good for which situation and which model can be bad for which situation. So next we will start with calculating this performance matrix for different machine learning models.